Very good evening to all my dear friends. I hope you guys are doing great and welcome to the revision through question series on RCC. So this session is on English channel. So the mode of communication will be English and total we are going to cover around 15 questions, 15 good questions by which your multiple concepts would be revised. So once again I am Aishwarya Sharma, Civil Wallah, welcoming you all on the platform Gate Wallah English. Okay, so my friends, let's start this session. Okay, so session is literally beneficial for those who are targeting GATE 2023. Okay, so let me start the session. So here is question number 1 on your screen. Question 1 is saying that in the design of beam for the limit state of collapse in flexure as per IS 456-2000, let the maximum strain in concrete be limited to 0.0027. We know that originally we do have, as per IS 456-2000, it is 0.0035. Instead of that, now they have taken strain equal to 0.0027. Okay. For this situation, we have to consider a rectangular beam section whose width is 300 mm, effective depth is 450 mm, and tension steel is 2000 mm square. Characteristic strength of concrete is M30, means 30 MPa, and for steel it is 250 MPa. Now they are asking what is the depth of neutral axis. Now they are asking, my friends, what is the depth of neutral axis. So what they are saying, we do have a rectangular section, and let's suppose we are having some area of steel. This area of steel is 2000 mm square. M30 is the grade of concrete and Fe415 is the, Fe250 is the grade of steel. Somewhere here let me have a neutral axis. Somewhere here let me have the neutral axis, and strain diagram here would be like this. So all other information we will keep same. Whatever alterations have been given, only that we are going to incorporate here. Okay, so no need to think much. Only the changed thing I am highlighting here. And we know that stress strain curve for concrete is parabolic up to a strain of 0.0020, and for the remaining portion it is constant. Okay, for remaining portion it is constant. So my stress strain curve will look like this. Now we know that for this portion we are going to have a constant stress of 0.45 FCK. Okay, and the rest of the things are same. So let me highlight here the stress, and that is equal to 0.87 Fy. Now friend, I need to find here what is this rectangular block out of the total depth of neutral axis. Let's suppose if this is the total depth of neutral axis, then out of this total depth of neutral axis, how much fraction is there which is under constant stress of 0.45 FCK, and how much fraction is there which is having a parabolic variation. So what can I do? If this distance is y, then from the concept of similar triangle, I can write here that it is 0.0027 upon XU is equal to 0.0020 upon Y. So Y is equal to 20 by 27 of XU. Y is equal to 20 by 27 of XU. So this value is going to be how much? This value is going to be how much, dear? It is 0.741 of XU. It is 0.741 of XU. Now what about remaining depth? So let's suppose the remaining depth is let's suppose Y dash. So Y dash is equal to 7 by 27. It is 7 by 27 of XU. So Y dash would be equal to how much it is? This would be, I hope you guys are keeping your calculator with you. So 0.259. It is 0.259 of XU. Now we have to find the neutral axis. We have to find here the neutral axis. So how we can find the neutral axis? How we can find the neutral axis? Just by equating, welcome dear Sarthak, just by equating compressive forces to the tensile forces. So total compressive forces in concrete would be generated due to this stress portion, whereas the stress on steel is constant. So if I am going to write the compressive forces equation, then it may look like, what is this area? This area would be rectangle area 0.45 FCK into Y dash plus this parabola area, this is a major portion of parabola, 2 by 3 into base into height. Okay, so this entire area would be multiplied by the width of the section. This has to be equal to 0.87 Fy into AST. So now solving this equation, we are getting 0.45, FCK is 30, Y dash is 0.259 XU into B. B is how much? B is given to you 300 mm. Okay, it is 300 mm plus 2 by 3 into base into Y is 0.741 XU. This is equal to 0.87, Fy is 250. Area of steel is also directly given to you. So my friends, on solving this equation, you would be getting here 142.66. So XU on solving this equation, it is coming out to be 142.66 mm. Okay, so let me check with which option it is matching. 142.66. So it is best matching with option number A. So option A is the right answer. Option A is the right answer. Okay, so I hope no doubts are there. So guys, you can share this session. I can understand that it is an English channel, so not much audience, and if you are liking this session, then please share it as well. Okay, so shall we move to the next question? Next question says that a rectangular beam of size 200 mm by 400 mm, okay, 400 is effective depth, it is subjected to a factored shear force of 50 at the critical section. Okay, the critical section of the shear resistance of the RC beam is 0.75 MPa, means they are talking about tau c value. Okay, and 2 bars of 10 mm diameter with grade Fe415 are also there, located there. Now they are asking, what is the maximum spacing of the two-legged 6 mm diameter mild steel vertical stirrups would be. So friends, topic is shear. Okay, topic is shear and subtopic is design for the shear. Okay, so here we have to see what is the maximum spacing of two-legged 6 mm diameter mild steel bars. Okay, so what all are the informations are given to us? We are given with the critical shear force. We are given with the dimension of the rectangular section. Okay, we are given with the value of tau c, that is 0.75 MPa. We are given with the bar diameter of 10 mm, but these are your main diameter. Okay, and Fe415 grade is also given to us. So first of all, I would like to calculate here the value of tau Vu. What is tau Vu? It is shear force divided by BD. Okay, it is shear force divided by BD. So the value of shear force which is given to you, it is already factored, and cross section is 200 cross 400 is the effective depth. So total, my friends, on solving this, you are going to get 0.625. 0.625. You can also cross check these calculations. I have done this calculation in advance, but since only one time I was able to solve it. So if you think that there chances are there that there can be some calculation errors, okay, I'll try that it should not be there, but you can also cross check my calculation. Okay, so this is the value of tau Vu, and what is the value of tau c? Tau c value is given to you 0.75 MPa. Here you can check that the developed value of stress, the developed value of nominal stress, or you can say average stress, is less than tau c. So theoretically we do not need shear stirrups. Theoretically we do not need shear stirrups, but yet we can provide some minimum amount of shear. Okay, we can provide some minimum amount of shear to take care of accidental torsions, shrinkage and all. Okay, so if I am going to provide that shear stirrups, because that provision is also given here, what is the requirement of shear? They are provided already 2 legs 6 mm diameter mild stirrups. Okay, so now just see here. So spacing, whenever we are going to calculate spacing here, so spacing of the shear is going to be minimum of these things. First, 0.87 Fy ASV upon 0.4 times of B. Second, 0.87 Fy ASV D upon VSU. Third, 0.75 of D. Fourth, 300 mm. My friends, this will not be required here. This will be required only if it will be required as tau Vu value is less than tau c. Had this tau Vu value would have been greater than tau c, in that case we need to calculate this. Here we are not getting the any excess shear force. So my spacing would be minimum of these three. My spacing would be minimum of these three. What are these three? 1, 3 and 4. 1, 3 and 4. Okay. So it is minimum of these three. This is not required to be calculated here. So this is 300 mm. Okay, not an issue. What is 0.75 D? D is given to you how much? 400. D is given to you 400, and 75 of D is again your 0.75 times of 400 is again your 300. Okay. Okay. So they both are same. Doesn't matter. You can pick any one. Now the whole thing would be determined based on this value. Whole thing would be determined based on this value. Now it is 0.87 grade C. Here usually students make a mistake. Generally you can see here whatever grade of steel is given here, that is for main bar. But when it comes to vertical stirrups, so there they have used mild steel. So do not try to put the value of 415 here, because the grade which are actually being used for stirrups are mild steel. It is not your HYSD bar. So what is the thing here? 250. What is the area of stirrups? 2 legged stirrups. What is the diameter of this? 6 divided by 0.4. What is the width of the cross section? Width of the cross section here is given to you 200. So you are going to get this result in mm. So on solving this, what you are going to get here? On solving this, I want to calculate it again. 0.87 into 250 into 2 into pi into divided by 4 into 6 square divided by 0.4 times of 200. So value is coming out to be 153.74. It is coming out to be 153.74. So you have to select this. You have to select this. So what is the nearest option which is matching? So 153.74, and here you can provide your option B. You can provide this stirrups spaced 150 mm center to center. Okay. Is it clear? So this you have to keep in mind, mild steel. So very in small font they have written mild steel, but we should know that whenever such stirrups are being used, so we have to use that grade of steel which is actually being taken for the stirrups, not for the actual bars. Okay. If no information would have been given here, in that case you could have proceeded with 415. Okay. Next is question number 3. Question number 3 is again from your shear, and it is the checking for shear. Subtopic is checking of shear. So two beams have been given to you. Similar question they have asked in GATE. So what I did, we simply interchanged the data. We simply played with the data. So two RCC beams are there, P and Q, and they are provided with an identical cross section. And what is the cross section? Cross section is 400 cross 750. Okay. And it is clearly written that this D 750 is effective depth, it is not the overall depth. Okay, we need effective depth only for the calculation of nominal shear. It is made with the concrete whose tau C max value is 2.1 MPa. All right. Okay. And for the percentage of reinforcement and for the particular grade of concrete, the value of tau C which is observed there is 0.75 MPa. Okay. Design shear in the beam P is 400, whereas in Q it is quite high, it is 750 kilonewton. Now considering the provision of IS 456-2000, we have to select the correct option. We have to select the correct option. What is option number 1? Welcome Archana. What is option number 1? Shear reinforcement should be designed for 175 kilonewton for beam P, and for beam Q it needs revision. Okay. Option 2 is saying normal shear reinforcement is required for beam P, and it should be designed 120 kilonewton for the beam Q. Okay. Shear reinforcement should be designed for 175 kilonewton for P and for 525 kilonewton for Q. Okay. And whether you want to design both the section, again both the sections needs revision. So all we need to check my nominal shear stress with the what? Value of tau C and tau C max. What is the value of tau C? Tau C is the minimum shear strength of concrete. Means without any shear reinforcement, what your concrete can take, that is known as the value of tau C. And with the help of shear reinforcement, what your concrete can take at max, that is known as the value of tau C max. Okay. So my developed value of tau C, okay, it should be less than tau c max in any case, because if that value is going to be increased, then we need the revision on the section. And if the value of tau vu is less than tau c, which is the minimum shear strength of concrete, that also in that case we do not need to design it for shear, or we can provide with minimum amount of shear. We need to design our section for shear only if my value of tau vu is going to lie between tau c and tau c max. Okay, so for that I have to draw the cross section of both beams. I need to find the value of tau v in both the cases. So let's see which section needs revision or what is the consequences. Okay, so similar cross sections have been given to you. Similar cross sections have been given to you. Let's suppose this is your beam P and let's suppose this is your beam Q. Okay, so this is your beam P, this is your beam Q. Dimensions are same. What are the dimensions? Dimensions are here 4 by 750, 400 by 750. It is effective only. Okay, it is effective only. Similarly here as well, it has to be effective only. It is 400 by 750. Okay, what is the value of nominal shear stress here? The value of nominal shear stress here is equal to Vu over Bd. What is the value of Vu here? The value of Vu here is, for P it is 400 kilonewton. What is B? 400. What is D? 750. So how much it is coming? It is coming out to be, just solve it. It is coming out to be how much? 2.5 MPa. Sorry, 1.33 MPa. 1.33 MPa. And similarly, if I am going to calculate tau Vu here, it is Vu over Bd, that is 400. Sorry, what was the value here? 750 kilonewton. So it is coming out to be 2.5 MPa. Now what is the value of tau c here? What is the value of tau c here? The value of tau c, it is 0.75. The value of tau c is 0.75. Okay, so in both of these cases, tau vu value is greater than 0.75, means at least we have to design it for shear. And what is the value of tau c max? The value of tau c max is given to you how much? That is, where it is, that is 2.1. That is 2.1. Tau c max value is 2.1 MPa. Now my friends, judgment is yours. We cannot exceed the nominal shear stress to tau c max, and here tau c max is 2.1 and here the developed value of stress is 2.5. So this cannot be designed. So section Q needs revision. Section Q needs revision. Okay, so let me check out my options once again. So section Q needs revision. Here they are saying, and here also they are saying section Q needs revision. Okay, so these two blindly you can make a cut mark. Okay, section Q needs revision. Now although they are also saying that both these sections needs revision, this is also sure that P doesn't need any revision because it is still in the permissible limit. But let me check it for option A, whether this is matching or not. Anyway, it has to match. So what is the value of axis shear stress. So shear force would be tau Vu minus tau C multiplied by B into D. What is tau Vu? 1.33. What is tau C? 0.75 multiplied by 400 into 750. This will give you answer in Newton. And so on solving this, my friends, you would be getting how much? You would be getting, yes, 175 kilonewton. You would be getting 175 kilonewton. It means that option A is our correct option. That is, section P can be designed for 175 kilonewton for the axis shear force, and section Q needs revision. Section Q needs revision. Okay. So heading towards the question number 4. Question number 4 says there is a rectangular simply supported beam and it is having a factored shear force at the center of the support, and that is 220 kilonewton. Okay. This beam is having two bars of 16 mm dia. Grade is given to you Fe415 at the center of the support on tension zone. Width of the beam is also given to you, it is 250, and depth of the beam is also given to you. Effective depth is M425. M20 is the grade of concrete. Now what is the minimum length of extension of main bars with 90-degree bend to satisfy the anchorage bond? So topic is bond and subtopic is development length. Okay, so how much additional length you guys are needing there? My friends, here first of all you need to find what is the length which you need in total to satisfy the bond criteria. Okay, so to satisfy the bond criteria. After that we will check how much we have provided and what additional requirement is still there. Okay, so if I am going to calculate the value of development length there, so what is the value of development length? Development length value, it is equal to 0.87 Fy pi upon 4 tau BD. And one more thing, this tau BD we are using for plain bar in tension, but here you can see that bar used here is Fe415, which is falling under the category of HYSD bar, and for HYSD bar we need to increase this value by 60%. We need to increase this value by 60%. Had this been a case of compression, then further it would have needed increment of 25%. But from whenever we are jumping from plain bar to HYSD bar, then it needs revision of 60%. Okay. So for M20, tau BD value is also given to you. So what is LD? It is 0.87. What is Fy? 415. What is the diameter? Diameter is 16 mm divided by 4 times of 1.2 into 1.6. So what development length guys you actually need here? So on solving this you will be getting how much? 752.187. 752.187. This is what you need. This is what is the requirement. Now it's time to check the availability. Now it's time to check the availability. And my friends, once again I am reminding you, please cross check my calculation with yours. I have solved them only once, that too in a hurry, and chances are there that these values are all right, but still there can be some discrepancy. Okay, so just double check my calculation with your calculation. Okay. Okay, now it's time to check the availability. How we can check the availability here? Okay, so for that what you need to do, you need to calculate the value of bending moment, you need to calculate the value of shear force. Okay, so based on that you need to calculate the value of availability. So how you guys are going to check for availability? Tell me. So this is 1.3. So condition says, as per code, my LD should be less than equal to 1.3 m1 over V plus L naught. Okay. So this you know that. Okay, before that, let me also calculate the value of m1. So how to get the value of m1? How to get the value of m1? m1. What is m1? It is 0.87 Fy into AST into D minus 0.42 XU. What is VU? VU is your factored shear force, and it is directly given to you. It is 220 kilonewton. It is 220 kilonewton. Okay. So here, if you are going to get the value of XU, then you can find the value of M1. So how you can find the value of XU? For getting the value of XU, you can simply compare your compressive forces with the tensile forces. So if you are going to do that, then it is 0.36 FCK B into XU is equal to 0.87 Fy into AST. So here you can see that XU is equal to 0.87, Fy is 415, and what is about area of steel? There are 2 bars of 16 mm diameter. So there are 2 bars of 16 mm diameter divided by 0.36 into FCK into what about B? B is 250. B is 250. So what is the value of XU? So XU value would be coming in the millimeter, and this value is coming out to be simply 80.62 mm. It is coming out to be 80.62 mm. Okay. Now we can find the value of M1. M1, as I said, it is 0.87 Fy AST into D minus 0.42 XU. So we were waiting for XU. Now it is 0.87, 415, 2 bars of 16 mm diameter into D. D was how much? 425 minus 0.42 of 80.62. This you will get in Newton mm. So finally your M1 would be in Newton mm. It would be how much? In your Newton mm, this would be in kilonewton meter. I have answer, so I will write in that. It is 56.75 kilonewton meter. This I want to recheck. This I want to recheck. Okay, dear. Okay. Thank you, Sarthak. So quickly let me recalculate this calculation. .87 F1 415. Okay, and 2 into pi by 4 into 16 square into 425 minus 56.78 I am getting 56.78 I am getting actually, or let me write it in Newton mm only, because I need to substitute it there as well. 56788,314.516 Newton mm. Now what I need to check? I need to check it for this condition. So here you can see that LD was coming out to be 752.187, 752.187 in mm. So for criticality condition, it is equal to 1.3. What is m1? M1 we just calculated, 56788,314.516 divided by, what about VU? VU is given to you 220 kilonewton. 220 kilonewton, so I am making it in Newton, the numerator in Newton mm plus L naught. So first of all, let me calculate this. So this is coming 335.56 plus how much L naught is given to you? L naught is the additional length. So additional length, what they have used here? They have used here 90-degree bend, and for 90-degree bend, what is the length available? For 90-degree bend, my friends, you are having 8 times of diameter. 8 times of diameter, what is the diameter? 16 mm plus add-on length, let's suppose L dash. So this is the condition, so 752.187, okay, 752.187 minus 335.56 minus 16 into 8. So the value of L dash is coming out to be 288.627. 288.627. Yes, exactly. So with what it is matching? It is a NAT type question. So what is the additional length required beyond the center of the support? 288.627. 288.627. Okay, mm. 288.627. So this is also the one of the good question from the topic bond. This question revise your the fundamentals of development length. It is also teaching you how to get the value of length of embedment like this. It is also making you utilize that what is the significant value for 90-degree bend. If hook would have been there, then it would be 16.5. Now it is 8.5. Okay, and if that is also not satisfying, then what additional can be calculated? So multiple concepts this question is covering here. Is it clear? Okay, so it's time to move on our next question. So next question is from torsion. Yes, next question is from torsion. So a RCC beam is there of size 300 by 600. It is subjected to factored value of shear force 100, bending moment 100. Shear force units are wrong here. Shear force units are wrong here. It should be kilonewton only. Bending moment 100 kilonewton meter, and torsional moment or twisting moment you can say as 34 kilonewton meter. Okay, so you have to find that for what moment you need to provide your longitudinal reinforcement. So all you need to calculate, my friends, here, that how you guys can calculate, how you are going to find equivalent bending moment. My friends, my longitudinal reinforcement shall be designed for mu equivalent, and this is equal to original bending moment plus converted portion of bending moment due to torsion. So let me tell you one thing. So my RCC is not that homogeneous material. So you have some conversion formula from your combined stresses chapter from strength of material, but those expressions we are not going to use here due to the non-homogeneous behavior of concrete. Okay, so what we are going to use here? So it would be original bending moment 100 kilonewton meter, Anybody, what is MTU? MTU is TU over 1.7 multiplied by 1 plus overall depth to the overall width. Okay, so it would be 100. So answer would be greater than 100 only. Answer would be greater than 100 only. So this and that, they both are already eliminated. So when it comes to torsion of 34 kilonewton meter divided by 1.7 into 1 plus, what about overall depth? If nothing is mentioned here, then I can take it overall. What about overall width? So 3 times we are going to increase it. So what is the value here? So on solving it, my friends, you would be getting around 60. So yes. So 17 to the 34, 20 into 3, 60. So 100 plus 60. So you need to get here 160 kilonewton meter. Okay. So option D. Here you have to select your option number D. Here you have to select your option number D. Is it clear? Okay. So let me move to the next question. Next question is from column. Column with helical reinforcement. Circular column with your helical reinforcement. Okay. So what question is saying that the ultimate load carrying capacity, of a circular column 300 mm diameter. Okay, just a minute. 300 mm diameter with helical reinforcement using 1% of reinforcement. Okay, and grades with M20 and Fe415. So with the helical reinforcement, my friends, I have to calculate the load carrying capacity. Only one basic thing you guys have to keep in your mind, that whenever your circular column is supported with helical reinforcement, then the load carrying capacity of the column increases by 5%. It increases by 5%. That is the recommendation from IS code. So whenever you are having a spiral arrangement, so you can think like that, due to the vertical component of helical reinforcement in upward direction, the increment in the load carrying capacity is going to be 5%. Okay, what is normal load carrying capacity? Normal load carrying capacity is 0.4 FCK a area of concrete. This is the actual stress at the time of collapse in concrete, and plus 0.67 Fy into AS. This is the developed value of stress at the time of collapse in your steel. Okay, this is under normal circumstances, but if it is to be designed with helical reinforcement, then 5% increment is there. So I am multiplying the expression with 1.05. Okay, so Pu is going to be 1.05. What is the stress? FCK value is how much? It is 20. What is the area of concrete? Total area of cross section. It is a circular section. So it is going to be pi by 4 into 300 square minus, you need to subtract the area of steel from here. So it would be pi by 4. It is 1% of. It is 1% of pi by 4 into 300 square, because area of steel is considered as 1% of the total cross section. Okay, plus 0.67 Fy into 1% of the gross cross section. So friends, if you are going to solve it, then you will be getting 793.78 kilonewton. 793.78 kilonewton. You guys can quickly recheck it. I think it is right. So it is best matching with option number D. So what things to be taken care here? So we have to read the word helical reinforcement very carefully. And we should also know, whenever there is a case of helical reinforcement, then my load carrying capacity of the column increases by 5%. Had this been a case of normal lateral ties, in that case answer would have been only due to this. It would have been only due to this. Are you getting it or not? Okay. Okay. So let me move with the next question. Question number 7. So in question number 7, they are asking, what is the maximum stress in tension steel if crack is not developed? Okay, if crack is not developed, in that case, what is the stress in the tension steel? So how you guys are going to tackle it? Crack is not there, means the stress value is less than, you can say, permissible stresses. The stress value is less than, you can say, is permissible stresses. What is permissible stresses in tension? It is 0.7 FCK. So do you think that grade is required here? Let's suppose, let me start this calculation without assuming any grade. Let's suppose I am taking any particular grade of concrete. Let's suppose I am starting with any particular grade of concrete. Okay, so just see here. Here, what is your flexural stress? It is 0.7 times of root FCK. Okay. What is your Young's modulus of concrete? It is your 5000 root FCK. Now, when it comes to strain, so strain is nothing. If this much we have to resist, then take it as a upper limit, FCR upon EC. So stress over Young's modulus of concrete is nothing but the strain developed. So this would be equal to, see, both are the function of grade of concrete, and in both the terms root FCK is there. So that is the reason without why grade has not been given here. So this is the value of strain. But we have to find the maximum stress in the tension steel. In order to maintain the strain compatibility, whatever strain is developed in concrete, the same strain has to be developed in the surrounding steel. Okay, because this is the surrounding concrete. Okay, so same amount of stress we need to prevent in your tension reinforcement. So stress developed in your stress in steel same strain multiplied by Young's modulus of steel. So strain is 7 by 50,000 into 2 into 10 to the power 5. So it is 140 by 5. So answer is 5 to the 10, 28 MPa. Very beautiful question, very well designed question. Okay, so no information is given, no information on grade of concrete, no information on grade of steel. Okay, so they are simply asking you what is the maximum stress in the tension steel if crack is not developed in the beam. So we should know that this is also known as modulus of rupture. So it is you can say maximum stress which your concrete can safely take before getting ruptured. Okay, so that is FCR. This is Young's modulus of concrete. We should know that it is also a function of grade of concrete. Even I was confused when I read this question. I thought something is missing here. Okay, so our final answer was there. Although final answer was there, that is matching. But I thought by mistake I have forgot to assign here some grade. So very well designed question. Okay. Okay, 28 MPa. Now it's time for pre-stressing. Now the question is from pre-stressed concrete. So they are saying that the initial pre-stressing force transmitted by a cable to pre-stressed concrete beam is 390 kilonewton. Okay, and it is to be noted that mechanism used is post tension, and wire area is given to you 325 mm square. Okay, then what is the percentage loss of wire due to the shrinkage of concrete? Okay, and it is also given that at 7 days it is going to be transferred, and the Young's modulus, instead of 200 GPa they are using 210 GPa. Okay, so all we need to find the percentage loss of stress in the wire due to the shrinkage of concrete. Although I have the final answer. Okay, first of all, my friends, you need to find what is the stress, what is the initial pre-stress, what is the initial pre-stress. So initial pre-stress, let's suppose P naught is equal to load upon area. So what is that? So that value is going to be 390 upon 325. It is exactly 1200 MPa. It is exactly 1200 MPa. Now you should also remember that if it is a case of your post tensioned pre-stress concrete, then what is the strain developed? Okay, so what is the value of strain developed here? So shrinkage strain is given to you. If it would have been pre-tension, then directly we could have taken 3 into 10 to the power minus 4, but here it is post tension, so shrinkage strain is equal to how much? 2 into 10 to the power minus 4, some logarithmic function, log base 10 t plus 2. Okay, so 2 into 10 to the power minus 4, so they need to transfer it at 7 days, so 7 plus 2. So if you are going to solve it, then what you are going to get, you are going to get here 2.096 into 10 to the power minus 4. 2.096 into 10 to the power minus 4. Let me recheck it. Okay, let me recheck it. I forgot whether I used base 10 or E. That's why I want to reconfirm. So log base 10 9. Yeah, exactly. 2.0.000209590. Okay, exactly. It is all right. Not an issue. It is all right. Okay. Next. What is Young's modulus of concrete? This is the strain. So Young's modulus of concrete is also known to you. Okay. So what is loss in stress? Loss in stress is equal to 2.096 into 10 to the power minus 4 multiplied by Young's modulus of steel, and Young's modulus of steel is also given to you, that is 2.1 into 10 to the power 5, that is 2.1 into 10 to the power 5. So this is coming out to be 44 MPa. This is coming out to be 44 MPa. Now the final step, percentage loss. Percentage loss is nothing but 44 divided by 1200 into 100. So answer is 3 point something. So answer is 3.67. Answer is 3.67. Answer is 3.67. And let me tell you one thing, loss due to shrinkage is literally high. So out of the overall loss is around 14 to 15% in post tensioned pre-stress concrete, and you can see that out of that 14-15%, only 3 to 4% is taken care by losses due to shrinkage. It is taken care by losses due to shrinkage. Okay. So next question. Next question is again from beam whose cross sections are known to you. Okay, effective span is also given to you. It is reinforced with 804 mm square and it is going to carry a total load of 16 kilonewton per meter. Okay, on the whole span. The stress produced in concrete, and yes, this is a beauty. They are asking the same question from the concept of working stress method. My friends, I agree with one thing that nowadays questions are not there in GATE from working stress method. But let me tell you one thing, directly they are not there. But indirectly, lot many applications are still be used based on working stress method. So that is the reason why I used to keep at least one question from working stress method in each of my session. Okay, because sometimes such modular ratio concepts they even ask in water tanks, sometimes in working stress method. Okay, so this is the basics. Okay, only one difference is there. Instead of calculating modular ratio from the definition of EST upon EC, we are calculating modular ratio by the mean of 280 upon 3 sigma CBC, which is taken care by, which is given by IS code by taking caring the effect of long term creep. Okay, partial effect they have considered of long term creep. So based on that they have computed this modular ratio. Now they simply wants to know that what is the value of stress which is produced there. So first of all, let me ask you that what is the total bending moment? What is the total bending moment there? So total bending moment there is bending moment. What is the value of bending moment? It is WSM, so no need to do the factor. Okay, and it is load 16 kilonewton per meter. This is simply supported. This beam is simply supported. Is this information given to you? No information given to you. So by default we will be carrying it, taking it simply supported. Let me add here simply supported beam. Because I have made the calculation as per simply supported beam. Okay, so this is 16 and what is span? WL square by 8. So what is this? 50 kilonewton meter. This is 50 kilonewton meter. Okay, so all we have to equate this bending moment with our moment of resistance, with this bending moment, because this we have to prevent. This can be the maximum cause. Okay, if my moment of resistance would be equal to bending moment, then what is that? What is MOR? What is MOR? It is sigma CBC by 2 or C by 2 into B into XA into D minus XA by 3. This is compressive force, this is lever arm. In working stress method, if this is my cross section, in working stress method, if this is my cross section, okay, and if this is my stress diagram, and let's suppose this is your compressive force, this is your tensile force, and this is acting at a distance of xa by 3, then the lever arm would be d minus xa by 3. Okay, but here what about d minus xa by 3? What about d minus xa by 3? So here d minus xa by 3 is the lever arm. So here we have to design it. Okay, and what about lever arm? What about lever arm? It is d minus xa by 3. In order to get the value of lever arm, first of all you have to find the value of xa. So how you are going to calculate the value of xa? Xa value can be computed simply either by equating compressive forces to the tensile forces, or when stress diagram is linear, so also you can equate the moment of area. You can equate the moment of area. They are one and the same thing. Moment of area about neutral axis. So how you are going to calculate that? It is b xa into xa by 2 is equal to m times of ast into d minus xa. Okay, what about b there? What about b there? B is 300. Okay, it is xa square by 2, m is 13.33. okay, what about ast? Ast is 804. What about d? D is 500. D is 500. So this is the 2-degree equation. So 150 xa square plus 13.33 into 804 into xa minus 13.33 into 804 into 500 equals to 0. So on solving this equation, you would be getting how much? xa would be your 156.63. 156.63 mm. Now same xa you need to put here. Same xa you need to put here, and you need to find the value of 50 into 10 to the power 6 Newton mm. C you need to find. B is 300. xa we just computed, that is 156.63. 156.63 multiplied by 500 minus 156.63 divided by 3. So here, so let me set the order. So because when you will be using sorry, this PDF, so this is my step number 1, this is my step number 2. Okay, after that I have to move to this step number 3. Okay, so on solving this, you would be getting C is equal to 4.75 MPa, 4.75 Newton per mm square. So answer would be 4.75. Maybe M15 grade they are utilizing. Okay, so this is the developed value of stress. This is the developed value of stress. Okay, are you getting it or not? So in English channel, students are not much. Okay, so next question is question number 10. Shear strength of concrete in RC beam is a function of which of the following? Okay, it is the function of compressive strength of concrete. Okay, it is the percentage of shear reinforcement. No, it is the percentage of longitudinal reinforcement in the tension side. Yes, this is also correct. It is the percentage of total longitudinal reinforcement. No, because this also include compression. So my friends, my tau c is the function of grade of concrete as well as the percentage of tensile reinforcement. So maybe this is of MSQ type question. So here you can select your these two. Option A, compressive strength means grade only. Option C, compressive strength, okay, uh, percentage of the longitudinal reinforcement in tension only. Please be reminded, compression reinforcement percentage is not used there. Okay, compression percentage is not used there. Okay, next question. A trapezoidal combined footing for two axially loaded column is provided. Good conceptual question. When do we have to provide the trapezoidal combined footing? My friends, trapezoidal combined footing will look like this. This is your trapezoidal combined footing. So they are asking when we need to find it. When we need to find it. Okay. Okay. First thing, the projection of the footing beyond the heavier column be restrained. Okay, is restricted. When width of the footing near the heavier column is restricted, length of the footing is restricted, width is no, this is incorrect because not an issue in width, you can extend it as long as you can. And projection of the footing beyond the heavier column, suppose this is your heavier column and let's suppose here do you have column. So when you are having some property line here, so you cannot able to provide your area here, so that is the reason why you are providing more width on this side. Okay, so this is the case of trapezoidal footing. So this is correct. Okay, and width of the footing near the heavier column is restricted, not an issue of width, this is also incorrect. Length of the footing, yes, this we also need to provide whenever the length of the footing is restricted. Okay, otherwise we could have looked for another alternative, dear. Okay, so that is the case. So in this case as well, your A and C, both the options will be correct. A and C, your both the options would be correct. Okay, so property line is here. This is, let's suppose, some property line. This is some of your property line and space restriction is there. Okay. Okay, next. In a reinforced concrete beam, the stress at extreme compression is 9.4. Okay. The depth of the neutral axis is 100. Okay. From the extreme compressive fiber. And grade of concrete is M20. Okay. Assuming the linear elastic behavior of the concrete, now what is the effective curvature of the section in per mm? This is again from the concept of strength of material. This is the application of your simple bending equation, my friends. Okay, this is the application of your simple bending equation. Okay, so we know that m upon I is equal to sigma by y is equal to E by R. So based on this we need to calculate this. Okay, so it is a beam case and stress at the extreme fiber is given to you. Okay, the depth of the neutral axis is given to you. Okay, okay, and grade is given to you. Grade means you will be getting the value of Young's modulus. And what is the curvature? So quite straightforward, curvature 1 by R is your sigma upon y into E. Okay, so this is curvature. What is the value of sigma? Directly given to you, it is your 9.4. Okay, and y is also given to you. It is 100 mm. 100, yes, it is 100 mm. All you need to know the Young's modulus of concrete, it is 5000 root FCK. What is FCK? FCK is 20. Okay, this is M20, so FCK is 20 MPa. Okay, so if you are solving it, then what curvature you are getting? You can calculate this. So it is coming out to be 4.2 into 10 to the power minus 6. 4.2 into 10 to the power minus 6 per mm. So option D, it can be matched with option D. Okay. Okay. So moving towards the next question, that question number 13. An RC slab simply supported on all the edges as shown in the figure, and it is subjected to UDL of pressure. So uniform pressure, let's suppose W of 12 kilonewton per meter square, or 12 kP is given to you. What is the maximum shear force per unit length along the edge AB? Along the edge AB, they are asking the maximum shear force. Okay. My friends, this is the application of your two-way slab. Okay. So how to calculate the value of maximum shear force in your two-way slab? So maximum shear force in your two-way slab is simply your W Lx by 3, 1/3 would be transferred. But W here, my friend, it is not 12, it need to be factored. And what is Lx? Lx is your shorter dimension. Lx is your shorter dimension. So this is 18 by 3 into 4. So 6. So answer would be 20. Quite straightforward. Okay. So maximum shear force here would be your how much? W Lx by 3. Okay. So this pressure needs to be factored by 1.5, and based on that you need to calculate the value of VO. Okay, thank you Jaspreet, thank you. Now late ho gaye dear, you are quite late today. Question number 14. An axially loaded short circular column 400 mm in diameter reinforced with 6 bars of 25 mm. It is provided with 8 mm diameter helical reinforcement at a pitch of 45. What is the safe load on the column? Okay, only pitch is given just to make sure that they have provided the helical reinforcement. My friends, safe load on the column would be what they are asking. So first of all, you need to calculate the ultimate load, then you have to divide that ultimate load by appropriate factor of safety, So what was the value of PU? PU is equal to 1.05 bracket 0.4 FCK AC plus 0.67 FY ASC. So first of all, let me calculate this. I am using 1.05 because it is a case of helical reinforcement. What about FCK dear? What about FCK? 20. What about area of concrete? Area of concrete is pi by 4 into 400 square minus 6 bars of 25 square plus 0.67. What about for FY415? Yes, 6 into pi by 4 into 25 square. Okay. So this on solving you are getting PU is equal to how much? 1890.705. 1890.785 kilonewton. Okay, this is the ultimate value, and P safe would be P safe would be PU upon partial factor of safety, that is 1.5 for dead load and live load. So that is how much? 1 to how much it is? I'm not able to identify my own writing. Let me divide 1890.785 divided by 1.5. So 1260.52. 1260.52. 1260.52 kilonewton. Rounded off to 1. So 1260.5. Okay. Yes. Is it clear? Okay. Okay. Now, last question. Last question of the session, my friends. Okay. I was expecting that it is from your pre-stressed concrete. So again the question is from post-tensioned pre-stressed concrete, and there is a cable of 10 meter long and initial stress is 1000 MPa at one end. Okay, the tendons are curved so that the slope is 1 in 24 at each end. Okay, means if this is your pre-stressed concrete beam and these are your, let's suppose, tendons, so they are having a slope of, let's suppose, 10 alpha, or alpha is simply 1 in 24. Okay, so they are being stretched from one side only, so jacking from one end. Okay, so what is the cross section is given to you? 600. Coefficient of friction between duct and cable, okay, mu value is given to you, and wobble correction factor is 0.0015 Newton per meter. Then what is the loss? My friends, whenever they are asking loss, then always we have to account the maximum one. So maximum loss will be accumulated here if jacking is done from one end, and if jacking is being done from both ends, then it would be located at the center, means in that case x would have been 5. So loss is equal to initial stress kx plus mu alpha. Initial stress is given to you, it is 1000, k is 0.0015, x is 10, mu value is given to you 0.3. Now what is alpha here? What is alpha here? My friends, here the total change in alpha would be with respect to this angle. So this is total, let's suppose 2 theta. So alpha is 2 theta here. What is theta? Tan alpha, or you can say tan theta, is 1 by 24. So alpha is 2 into, and angle is small here, so this is nearly theta only. So 1 by 24, so total it is 1 by 12. So if it is total 1 by 12, then let me keep here 1 by 12. So on solving this, my dear friend, loss would be 0.015 plus solve it, and you would be getting exactly 40 MPa, 40 MPa. So no need to round, it is coming in exact figure. Okay, so this is the answer key, this is the answer key. Okay, so quickly we can check our answers. A, B, A 288.7, A, B, A, and here 288.62, okay, 288.7, okay. First four we have checked. DD 28.3 to 4, D 28. This one is my favorite in this series. This is my favorite. And what about this? 3.67, 3 to 4, okay, 3.67. So up to 8 we have verified. Okay. Now 4.5 to 5 AC ACD. Yeah, 4.75, okay. A, C both are correct. A, C both are correct. This D is also correct. After that 24, 12, 60, 40 or 40, 12, 60 and 24 exactly. Okay, and I'm quickly following the entire slides so that in case you are not receiving PDFs and all, you can get it. So I am on one side. First question continued. Second question continued. Third question continued. Fourth question, fourth continued. Fourth continued. Fifth question, sixth question, seventh question, eighth question, ninth continued, 10th, 11th, 12th, 13, 14 and 15. And this is your answer key. You can match it. So my friends, that's all from my side in this session. I hope you guys are liking this session, although not many members are there, but yes, whenever you will be teaching this, watching the same in offline mode, so I hope you will be liking these questions. Okay, so thanks a lot, take care, stay safe, we will be meet very soon. And yes, one more information is there, although that is for Hindi channel. I have taken the Maha revision sessions on RCC, so only pre-stressed topic was left. Okay, as promised, I will cover that topic, and I will be covering that before 2nd of Feb. Okay, so that is going to be my last session for GATE 2023. After that, we will be meeting in new session, guys, on YouTube. Okay, so bye bye, have a great day ahead. Bye bye.